Hello everyone, this is question number 10 of June 19, paper 1. So the question asks us, for part A, the question asks us to expand 1 plus 2x squared, a bracket to the power minus 1 by 3 in the ascending powers of x, up to and including the term x to the power 6, expressing its coefficient as an exact fraction in its lowest term. So for part A, uh, 1 plus 2x squared to the power minus 1 by 3 is in the form of a plus bx squared to the power d, where a is equals to 1, which is a good thing for us, so the expansion will be much more easier, and b equals to 2 and d is equals to minus 1 by 3. So a plus bx squared to the power d, or a plus bx to the power d. The expansion will be, the process will be the same, just you will have to use x squared or x. If the expression is given in terms of x squared, then the expansion will also be in terms of x squared. If it's given in terms of x, then the expansion will be in terms of x. So over here, we're given in terms of x squared, so we'll use x squared. So the expansion will be 1 plus dbx plus d multiplied by d minus 1 divided by 2 multiplied by 1 multiplied by dx squared. Sorry, there would be an x squared here. So x squared whole square. And it would be d minus 1 multiplied by d minus 2 divided by 3 multiplied by 2 multiplied by 1. And it would be bx squared to the power 3. So we'll expand it up until this, because we'll get x to the power 6. If you do this, then let me rewrite this. So it would be x squared. So 1 plus 2x squared to the power minus 1 by 3 would be 1 plus d is minus 1 by 3, and b is 2, and x squared plus d is minus 1 by 3, and it will be multiplied by minus 1 by 3 minus 1 divided by 2 multiplied by 1, and b is 2 x squared to the power 2 plus d is minus 1 by 3 multiplied by minus 1 by 3 minus 1 multiplied by minus 1 by 3 minus 2 divided by 3 multiplied by 2 multiplied by 1, and b is 2 here, x squared to the power 3. So the expansion will give us 1 minus 2 by 3 x squared plus bracket 2 by 9. This comes from this part only, multiplied by 4x to the power 4, bracket close, plus minus 14 by 81, 8 x to the power 6. 3 multiplied by 2 is 6. And the next line would be the 1 plus 2x squared to the power minus 1 by 3 would come out to be 1 minus 2 by 3 x squared plus 8 by 9 x to the power 4 minus 112 by 81 x to the power 6. And that is it for part A. We also have given the answers in fraction in their lowest term. So what they mean by lowest term is that, for example, if you have 4 by 8 as a fraction, this isn't in a lowest term. It might be a fraction, but it's not in the lowest term. The lowest term would be 1 by 2. So the lowest term means this. So for part B, we have been asked to state the range. So for finding the range, it's important to look at whether the expression is in a plus bx to the power d, whether it's in x or x squared. So when it is in x, it would be written as minus a by b, less than x, less than a by b. And if the expression is in form of x squared, so a plus bx squared to the power d would be minus root over a by b less than x less than root over a by b. So our expression is in x squared. So it would be 1 plus 2x squared to the power minus 1 by 3. So it would be minus a is 1 and b is 2, less than x, less than root over 1 by 2, and root over 1 by 2 also can be written as this in this form. So root over 1 divided by root over 2 less than x less than root over 1 divided by root over 2. Root over 1 is just 1, so you can just write it like minus 1 by root over 2 less than x less than 1 divided by root over 2. So this is it for part B. You could also give the answer in this form. It really doesn't matter. So for part C, we have been given fx. Fx is equals to 2x plus 2 plus kx squared divided by 1 plus 2x squared to the power 1 by 3. So obtain a series expansion for fx in ascending powers of x up to and including the term x to the power 6. Give each coefficient in terms of k where appropriate. So fx is given, so for part C, fx is equals to 2 plus k x squared. I think it's x squared, right? Yeah, x squared. Divided by 1 plus 2x squared to the power 1 by 3. 2x squared to the power 1 by 3. And this can also be written in this form. So 2 plus kx squared multiplied by 1 plus 2x to the power minus 1 by 3. What we did here is this, that when it's, for example, a by b squared, so this can be written as a multiplied by b minus 2. So when you just take the denominator and multiply it with the numerator here, the power will, if the power is positive, it will turn negative, and vice versa. So we have already expanded 1 plus 2x to the power minus 1 by 3 in part A. So we can just write that. So 2 plus kx squared multiplied by what we got in part A, which was 1 minus 2 by 3 x squared, 2 by 3 x squared, right? Yeah, plus 8 by 9 x to the power 4 plus 8 by 9 x to the power 4 minus 112 divided by 81 to the power 6. 112 divided by 81 x to the power 6. Now we have to multiply 2 with the expansion of part A at first. So 2 multiplied by 1 is just 2. So 2 plus 2 minus actually 2 minus 2 2 multiplied by minus 2 by 3 would be 4 by 3 x squared, and 2 multiplied by 8 by 9 would be plus 16 by 9 x to the power 4, and 2 multiplied by minus 112 by 81 would be minus 224 by 81 x to the power 6, plus now we have to multiply kx squared with the expansion of part A. So this would be just, at first it would be kx squared multiplied by 1 is just kx squared minus 2 by 3 kx to the power 4, and then this would be plus 8 by 9 k. The powers will get added up. 4 plus 2 would be 6 because they are in the multiplicative form. So x squared is multiplied by x to the power 4. So it will become x to the power 6. And we don't need to write any further because kx squared multiplied by minus 112 by 81 x to the power 6 will actually be x to the power 8. So x to the power 8, we don't need to do that because they have asked us to give up to x to the power 6. So we don't need that. So you can just expand up to this. And then we can write it in this form. Can bring the same powers together. So 2 minus 4 by 3 x squared, I will write it with kx squared here, and plus 16 by 9 x to the power 4 would be written with minus 2 by 3 kx to the power 4 minus 2 to 4 by d1 x to the power 6 could be written with 8 by 9 kx to the power 6, 8 by 9 kx to the power 6. And now fx will have to be written in terms of their coefficients of x, right? Give each coefficient, so we have to write it in terms of their coefficient. So that means that 2 will remain as 2, but this would be x squared, and this would turn out to be 4 minus 3 plus k. So the coefficient of x squared is 4 minus 4 by 3 plus k. They have asked us to write it in this form. Plus x to the power 4 is 16 by 9 minus 2 by 3k. Minus 2 by 3k. And plus x to the power 6. This would be minus 2 to 4 by d1 plus 8 by 9k. So that is it for part C. And for part D now, let me go back to the question. Given that the coefficient of x to the power 4 in the series of expansion fx is 0, so they have already given that the coefficient of x to the power 4 is 0. So let me write down the coefficients at first of all the coefficients in the expansion of fx. So the coefficient of x squared is minus 4 by 3 plus k. This is what we got from our expansion. The coefficient of x to the power 4 is 16 by 9 minus 2 by 3k, and the coefficient of x to the power 6 is minus 2 to 4 by 81 plus 8 by 9k. So they have given that the coefficient given that the coefficient of x to the power 4 is 0. So we know that the coefficient we got, or the coefficient of x to the power 4 is 16 by 9 minus 2 by 3k. So we can just equate this right now. So it is 16 by 9 minus 2 by 3k brackets is equals to 0. And this is a simple solving problem right now. So 2 by 3k, and k would come out to be 8 by 3. So you multiply 16 multiplied by 3 and 9 multiplied by 2, you will get 8 by 3. For those who are confused about what coefficient is, the coefficient is actually a constant that is multiplied with a variable. So here, the constant is minus 4 by 3 plus k. This would come out to be a constant, and which is multiplied with a variable. So the variable is x squared here. So coefficient is the constant. So this is what coefficient means. So for part E, hence use the algebraic integration to obtain an estimate to 4 decimal place of this. So this is integration now. But for doing that, I will be writing fx, actually E. This is E. So what we got fx to be 2 plus x squared minus 4 by 3 plus k plus x to the power 4. Sorry. X to the power 4 multiplied by minus 6, sorry, not minus, 16 by 9. 16 by 9 minus 2 by 3k. By 3k, and plus x to the power 6 plus minus 2 to 4. X to the power 6 plus minus 2 to 4 by t1 plus 8 by 9k. So 8 by 9k. And now we'll substitute the value of k into this expansion of fx. K was 8 by 3. So fx is fx just, and 2 plus x squared square brackets minus 4 by 3 plus 8 by 3 bracket close plus x to the power 4 bracket 16 by 9 minus 2 by 3. K was 8 by 3 bracket close plus x to the power 6 and brackets minus 2 to 4 by t1 plus 8 by 9. K is 8 by 3 bracket close. So this would be 2 plus 4 by 3 plus 4 by 3 x squared, and this would come out to be 0 if you see 16 by 9, and 2 multiplied by 8 is 16, and 3 multiplied by 3 is 9. So this would be plus 0 x to the power 4, which would be 0 eventually, plus x to the power, sorry, plus it will be minus 32 by t1. So minus 32 by t1 x to the power 6. So finally, fx would be 2 plus 4 by 3 x squared minus 32 by 81 x to the power 6. Now we'll have to integrate fx. We have been given limits of 0, 0.5. Integration of fx in terms of dx. because fx is in terms of x, so we have to integrate in terms of x as well. So integration 0 and 0.5, fx is 2 plus 4 by 3 x squared, 32 by 81 x to the power 6 dx. This would come out to be 0, 0.5. So sorry, let me integrate this. So integration of 2, the integration of 2 would be 2x. So integration of 2 would be 2x, because 2 is actually 2x to the power 0, and we integrate things in this form. So let me just write it here. So integration of, for example, ax would be ax 1, ax, actually x is x to the power 1, so 1 plus 1 divided by 1 plus 1, right? So here, integration of any constant is actually also integration of any constant is, for example, a is 2, so it's actually x to the power 0, and we don't write x to the power 0 is anything to the power 0 is 1, so we don't write it. So it would be ax 0 plus 1 divided by 0 plus 1, which would just be 1. So this is what we got for the integration of 2 plus 4 by 3 x 2 plus 1, and this would also be 3 multiplied by the 3 that was there in our fraction, and 3 plus 1 due to integration, minus 32 by d1, and it's x to the power 6, so 6 plus 1, and multiplied by 6 plus 1, and limits, because we have limits, we don't need to write a k at the end of the integration. So this would turn out to be, oh, did I write it right? There is a mistake, it's 2 plus 1, so it's 2 plus 1, so this would be 2x, and 4 divided by 3 multiplied by 3 is 4 by 9 x to the power 3, minus 32. 81 multiplied by 7 is 567, so 567 x to the power 7, bracket close, and the limits are 0.5 and 0. Now we have to work with the limits. So at first I will work with 0.5, the upper limit. So this would be 2, 0.5, 0.5 is a plus here, so plus 4 by 9, 0.5 cube, and minus 32 by 567, and 0.5 to the power 7. Let me rewrite this. 7, and we will work with 0 now. So this would be 2 multiplied by 0 plus 4 by, this would be 4 by 9, bracket 0, 0 to the power 3, minus 32 by 567, 0 to the power 7. So If you solve this first square bracket, then uh, you will get 1 point, sorry. So this would be 1.05511. So I think they asked us to give it in full decimal place, right? So yeah, full decimal place. So this would simply be 1.0551. No change. So this is the answer for this, for part E. Thank you.